Good day. Thanks for joining us. At this session, Fola and I will share stories of building DDoS-protected web applications, best practices of incorporating resiliency at all layers, and responding to DDoS attacks effectively and efficiently. My name is Dmitry. I am a solutions architect at AWS, and recently I teamed up with an organization to build an unusual project. I have always been passionate about spreading knowledge, and the last year, when many people switched to online learning, with a friend of mine, we saw an opportunity to help people with studying from home and build an online learning platform for dogs. Well, not specifically for dogs, although I received a few requests to have sessions translated into dog language, but rather for owners to upskill in the science of the smart pets. The core of the platform are life lessons with experts, so any disruptions would be critical for students and annoying for dogs. First and foremost, right from the start, I had a goal of incorporating DDoS protection into the application. Nothing should put the best customer experience at risk and interrupt their learning process. When I told this to my friend and the business owner, she insisted that we should rather fully focus and put all our energy into developing the application, leaving everything else to later stages. We had so much to do. To convince her, I shared what I saw recently. Spikes here are successfully reflected attacks. However, if unmitigated, each of them could mean a disrupted business and a scary news story, whereas I wanted the learning business to succeed. So, in my journey towards a DDoS-protected workload, I had to answer these questions. How can I take the most AWS has to offer? How do I automate as much as practical? Most importantly, alerting and response. When I still have to respond, what do I do and how can I work shoulder to shoulder with security experts? Combined, they form a goal of building the DDoS-resilient application that is online no matter who tries to attack it. Let me share with you how I answered these questions. To start with, I explored the common risks for web applications like mine, and they fall into three broad categories. The denial of service is specifically challenging because it targets multiple layers and often is distributed, making an attack amplified against a single target. Turns out, AWS provides protection from some of the threats by default, making my task easier. Under the hood, AWS mitigates attacks at multiple layers throughout a network before any traffic even reaches services I use for my application. This built-in defense in depth is a powerful mitigation mechanism. Everything starts at the internet layer mitigations and on border network. Here, AWS works with telecom carriers and peers and communicates how they should be handling traffic, what they should do with it, how to increase AWS, should it be blocked, should it not be blocked. As traffic flows further, it goes through network layer mitigations which take advantage of the system that AWS has built. And it's quite clever. It provides not only network mitigation at the border, but a tight level of integration with the platform. So there is communication between the system and the network border and downstream components. What that means for my workload is that AWS mitigation system has context of its type and size. If there is an attack, the protective logic understands what my systems can handle and also the composition and type of traffic that should be destined for it. When we release a new online training and traffic spikes, but simultaneously there is an attack, this protective logic is smart enough to clearly distinguish one from another and drop only malicious traffic. Also, there is a built-in protection into AWS services themselves. Every AWS service is built to be able to handle floods of traffic and to be able to block and drop traffic that is not intended for an application, keeping it online. Throughout the session, we will explore the services in more detail. This means DDoS attacks happening at network layers are taken care for me by AWS. Their part of responsibility is to ensure such attacks don't impact my infrastructure. Builders have less to worry about, and the main focus for protection is at higher application layers. That combination of defense and depth we just walked through is AWS Shield Standard, which is a default and automatic threat protection service for the first point of entry for application traffic. In an ideal world, that would be it. I would be helping students and their dogs to learn online, not worrying that anything can damage their experience. However, as we saw, there are other types of DDoS attacks, and therefore we need additional steps to address them. The framework for building the comprehensive DDoS resiliency on AWS relies on 3 pillars. Each of them helps with the questions I said initially and actionable steps to get the answers. And let's walk through them one by one, starting with preparation, which is arguably the most important of them. As Benjamin Franklin once observed, an ounce of prevention is worth a pound of cure. Everything starts with the architecture that uses services that have the best DDoS mitigation capabilities. The online learning platform I am building has quite a common architecture and takes advantage of VPC features to reduce attack surface. I place the logic in private subnets, and it's accessible only via the load balancer. Security groups and knuckles allow me to set only network ports and protocols I know my application should communicate through. Ability to scale out is critical for a successful response to an attack. A sophisticated, high-volume DDoS attack usually has unknown fingerprints that may require some time to reveal and apply countermeasures. During that time, the workload that takes full advantage of elasticity keeps being online and provides value to end users. And that's exactly my main objective. So, at each tier, I apply the elasticity mindset. Autoscaling Group takes care of that with the fleet of all my EC2 instances. Application Load Balancer has this capability by design. It absorbs floods of requests, both from students and, if it happens, from bad actors, and scales out automatically when needed. As the goal is to use the most resilient architecture, the learning platform takes advantage of the globally distributed edge locations and services that operate from the edge network for the best overall defense. I rely on Amazon CloudFront for content delivery, AWS WAF for blocking application layer attacks, Route 53 for serving DNS. Let me share with you a story of one of the typical attacks on my application and break down the architecture to decompose each component's role. CloudFront delivers my content from infrastructure that is closer to end users. During the attack, the routing logic fanned out DDoS traffic to many edge locations and prevented it from focusing on one point. That is a powerful mechanism to disperse and isolate an attack to mitigate smaller portions of it close to its sources. Shield DDoS mitigation service also continually inspects traffic and allows only valid requests to reach my web applications. It automatically mitigated network layer attacks and maintained persistent valid connections with application origins. Live streaming sessions were not interrupted at all. So, placing CloudFront in front of API Gateway or load balancers is a step towards better DDoS resiliency. AWS WAF plays equally important role with custom rules and sets of managed rules. When the attack hit, Amazon IP reputation list blocked IP addresses typically associated with bots and other threats. That reduced bot networks from which the attack could hit. Second, and most important, was the RAID-based rule, which blocked source IPs that were sending more requests than I allowed in the rule. I know that students of my platform and dog fans come from legitimate IP networks and don't generate more than a few hundred of requests a minute, even when excited to learn everything. The rest most likely has all criteria for being a DDoS attack, and I let the WAF rules to take care of it and block for me. Route 53 shares most of the same protection mechanisms with CloudFront. It evaluated and validated that traffic composition was most likely coming from a human user and prioritized accordingly, whereas DDoS-like traffic was automatically blocked and dropped. The main takeaway is that the edge services significantly improve DDoS protection in addition to performance. They all include Shield's standard, and with a few extra steps that I covered, even as most sensitive for disruption workload as Life Lessons platform becomes resilient against disruption. DDoS resilient architecture, intertwined with extra response, monitoring and mitigation capabilities from Shield Advanced, maximizes protection and ultimately helps me to answer the questions I had when set the goal. And let's explore how. First, to create a customized baseline profile of a certain protected application. Life Lessons generate quite a bit of traffic and at the same time very sensitive to any latency fluctuations, let alone disruptions. With the sensitive thresholds and thorough visibility into patterns of traffic, AWS mitigation systems start blocking unwanted traffic earlier and do it seamlessly. So I can be confident that the user experience is not at risk. I mentioned earlier that sophisticated, high-layer, high-volume attacks need some time to fully mitigate. During that time, CloudFront and other services of the architecture scale up and to absorb floods of requests. Protection from Shield Advanced enables refunding the charges of usage spike from the attack, such as extra data transfer or additional instances. With that protection, I never need to trade off availability and user experience against cost saving. With access to Shield Response team, I'm no longer one-on-one with a DDoS event. When engaged, the team is actively involved in analyzing the attack to block it as soon as possible, using all the tools, knowledge, access to underlying infrastructure they have in their disposal. In a few minutes, my friend from the Shield team will share one of such interesting stories. The last one enables detailed visibility and alarm notification of events with rich metrics that can be used as an input for feedback loop for constant improvement of the protection at the edge. When I incorporate Shield Advanced into architecture, enabling protection for the components is an important step. With the protection enabled, Shield consumes data from components on the way of traffic flow to build a traffic baseline for my application. It moves the mitigation effectiveness to the top level and decreases false positives. For a couple of services, I do an extra step to take the most out of Shield. As a builder, I use Route 83, and that alone gives that protection I mentioned earlier. One step further is to create health checks for all resources I want to protect and associate them with Shield Advanced. The main benefit is integration with proactive response with the Shield Response team to give them ability to see potential degradation of availability and a function to start mitigation of the attack on the learning platform. AWS WAF logs are invaluable. During my first attack, I learned that it's important to enable them while preparing as early as possible, and then they are streamed into an S3 bucket. For the Shield Response team, these logs play an integral role during the time they are engaged. They analyze patterns and signatures of the attack to find the most effective countermeasures. Imagine having a bodyguard, actually a team of bodyguards who have your exclusive permission to take your pet out of any trouble in any tricky situation. So, the extra step after enabling the logs is to provide the team with access to these logs in Shield Advanced. Following the general best practices for multi-AWS account strategy and quickly realizing that the learning platform becomes sophisticated and requires more moving parts, such as additional CloudFront distributions, application load balancers, and API gateways, I faced a dilemma of keeping all of them protected sustainably. Put simply, how to avoid additional operational overhead with growth of amount of moving parts. The solution is to use AWS Firewall Manager. Specifically, it solves a few important aspects. Firstly, it becomes just a matter of a couple of clicks to associate WAF of WebACL with all the resources I want to protect with it. What's most powerful is leaving Firewall Manager to take care of compliance for all new resources. The application I'm building is still at its early stage, and with time, new resources will be introduced, potentially on the daily basis. I love continuous deployment and automation, so leaving them unprotected and having to spend time to fix it or making CI/CD pipelines unnecessarily complex doesn't look fascinating. Firewall Manager automatically associates WebACL to resources that are either new or, for whatever reason, become unprotected across all AWS accounts and resources that are part of the security profile. One of the steps I mentioned earlier is enabling Shield Advanced protection on resources. In the similar fashion with WebACLs, Firewall Manager enables that protection automatically, if I choose so. As a main takeaway here, rely on the service to enable the self-sustainable mechanism with protection from WAF and Shield Advanced. Once everything is prepared according to best practices, it's time to move further and ensure an attack is under control. Monitoring is a mechanism to accomplish it. Shield Advanced enables a number of metrics in CloudWatch that underpin any solid DDoS protection strategy. These real-time metrics indicate a volume of an attack that, combined with vector dimensions, reveal attack's nature in detail. They make it possible to construct dashboards and alarms. One of the metrics is a backbone and functional enabler of many capabilities. Its name, DDoS Detected, and it enables alarming, puts it on a dashboard, and triggers sending a notification to an SNS topic and therefore to any preferred communication channels such as email or SMS. Down the line, through integration with many third-party systems such as Slack and PagerDuty, enables alarming of attacks into pretty much any destination. I mentioned how WAF logs are important and why enabling and storing them is vital. It's worth repeating, especially the part that they should be enabled at a preparation stage and not when an attack is ongoing. Shield Advanced changes the way that it monitors protected resources and allows me to receive notifications when an anomaly is detected. During one of the busy days, when someone triggered a massive attack on the learning platform, I suspect the pesky cat community, Shield Advanced Console provided me with the summary of events. From here, I could see resources impacted, which was helpful to gauge the scale and identify potential damage. It also provided me with quick links to drill down to each of the ongoing attacks to investigate more. The summary here is a useful mechanism for me for an input to the feedback loop for reinforcing DDoS protection. The details provide insight into the nature of the attack, its vectors, originating IPs, volume, source countries, and other useful information. They give ideas and direction for configuring additional rules in AWS WAF. For example, implementing geo-based blocking. Knowing exactly how to respond during an event is that last element that behind the scenes makes students of the platform focused on studying and not on being upset with a disrupted lesson and barking from exasperation dogs. Every minute matters, and the cost of a delay grows exponentially during an ongoing event. Multiply this on pressure of an attack, and you get quite an intense scenario. The main goal for a response to a DDoS attack is to maximize efficiency and effectiveness of protective countermeasures. I rely on automation as much as practical to win time, eliminate potential mistakes, and execute steps that are already tested and work. CloudFront, Application Load Balancer, and Route 223 scale up automatically when they receive more traffic to absorb it. Autoscaling group is a component that I need an extra step with. I use CloudWatch DDoS detected metric to trigger scaling out of a group of EC2 instances. Whenever an attack is detected, the fleet of instances proactively scales out to extra 30% capacity. With that, I win time to explore impact and decide my following steps and mitigation actions. AWS WAF managed rules, or custom regular ones, automatically block unwanted traffic, and that's all good. With clever attack, though, that disguises normal traffic, we need extra measures. The rate-based rule is a great mechanism to automatically block IPs that generate floods of seemingly normal requests. During events, I use attack signatures to craft custom rules, and then, with Firewall Manager, protect all my resources with a single action, assigning the new rule to them. That significantly saves time and allows to react effectively and efficiently. Automation and scalable way to apply WebACLs significantly reduce necessity for me to escalate to experts. Normally, I would create a support case with highest possible severity, and experts from the team would rapidly react. Much better option is configuring Shield Advanced Proactive Response, which allows me to rely on automation, and the team will directly contact me when they detect health degradation of my application by a suspected attack. Just an idea that you have a plan isn't enough. Let's explore what's better. Having a plan as a written document is a great starting point. Include these topics in it: review of CloudWatch or custom dashboards and Shield Console for ongoing events. Identify availability or performance concerns, reading key metrics. Review of WAF sample requests and logs for unexpected characteristics that can be used for crafting a new blocking rule. Escalate to experts if necessary. No doubt that the runbook should be accurate. For me, it's a good practice to review it quarterly or after major updates in the architecture that change the dynamics of the response. Great mechanism to ensure it's up to date is testing. I'm a fan of testing, and I was glad to know that I can do DDoS simulation testing on AWS. Working with AWS DDoS test partners makes it straightforward, and it doesn't require approval from AWS. The initial test I did revealed a few improvement opportunities which proved their usefulness during the very next real attack. Once a year now, I have these fire drill exercises to ensure everything is tested and ready. It also builds the response muscle memory. With that, all three pillars are completed. And let me hand over to my friend Fola. He and his team are based in Cape Town. He has a story to share. Over to you, mate.
Thank you very much, Dimitri. Hello, folks. My name is Fola. I'm a security engineer on the Shield Response team. My team is a group of security engineers who are specialized in DDoS response. We are a 24/7 team that assists our customers both internally in AWS and Amazon, as well as external customers who are Shield Advanced customers with response to DDoS events or DDoS attacks. Today, I'll be walking you through an example of a DDoS Shield, a Shield Advanced escalation, so you can have an idea of what it is to expect when you escalate to the Shield Response team. So I'm going to walk through an example here. In this case, we received a Shield proactive response alert notifying us that Dimitri's application was under attack. And so as with our Shield Response escalation process, we created a communication channel with Dimitri. We reached out to the primary responder and let him know that we have noticed that his application is being impaired and there is an ongoing DDoS attack. Dimitri's primary responder reached out to us and we began to triage. But before I proceed, I would like to quickly walk through the application's architecture. We can see that the application is using a CloudFront distribution, WAF, auto-scaling, and application load balancer. And this is actually in line with our recommendations and best practices. But we quickly realized something was afoot here. The login wasn't enabled for this application, so that the Shield Response team was unable to get the incident fingerprint or the attack fingerprint in order to mitigate this attack. So this is an example of what it looks like on the console. You will see if your login is enabled or disabled. In this snippet, we would want customers to enable comprehensive login for their WAF, as this allows us as the Shield Response team to have access to look at your attack patterns. So we had to assist the customer in enabling this. This takes some time. Unfortunately, during this time, the attack intensity increased towards Dimitri's application, and you can imagine he was in pain, and we were only able to identify the attack pattern after the login had been enabled. So the first snippet I'm going to walk you through here is when we began to analyze this attack. We looked through the logs and we identified something strange. I just want to call out real quick that the snippet you see does not contain the user agent that we saw during the attack. This is just something generic so that you have an idea of what it may look like. And this attack cost, this was the main contributor to the attack, and we had to quickly generate a way to create a WebACL rule to mitigate this one signature. After we identified this, we created the WebACL rule in count mode. We saw progressive increments in the rule count, and we then decided with Dimitri to flip it to block mode. The DRT will not flip that to block mode without your consent. Once in block mode, we saw that the application was recovering, and the request count was continuously reducing. And this gave us confidence that the mitigation was successful. We were just about to pop champagne and celebrate that we were successful in mitigating this attack when we saw the request count begin to progressively increase again. So this time we were more prepared with access to the logs, and we quickly ran through the logs to identify the next attack pattern. In this attack pattern, we noticed that the attacker wasn't using a cookie string that was expected by Dimitri's application. And so what we did in that point was we decided to search for any HTTP request without a certain pattern of a cookie string and drop those requests. We did this, we modified the rule, added this rule into the WebACL, and we then put it in count mode to detect or to monitor how the impact of this rule would be in block mode. Once we saw we were satisfied with that, we flipped that to block mode, and sure enough, that took care of the attack. Before we dropped off the call, the Shield response team usually likes to leave some recommendations to the customers. And so in this case, we left recommendations that Dimitri should use Firewall Manager to propagate this change we have implemented across his entire fleet. So that's it for the Shield response team. Back to you, Dimitri.
Thanks, Fola. That was awesome. You and the team saved me. Through a few iterations and incorporating all the best practices I shared, the learning platform is always online, no matter what a rainy day brings with it. Let me summarize the key learnings and most impactful actionable items. The more you spend on preparation, the less stressful will be the incident response. While building, follow the architecture best practices for DDoS resiliency, globally distributed network capacity, and use services with DDoS resiliency. Use WAF with all web-facing endpoints and enable logging from start. Consider Shield Advanced and protect all resources with it, which enables detailed visibility that in turn underpins rapid response. Invest effort and time into incorporating automation into the response. WAF rate-based rules, automatic scaling, seamless escalation are one of the most useful examples. Shield Response Team is, in my view, one of the most valuable parts of Shield Advanced. Enable proactive response to ensure experts jump on solving a potential problem before it becomes a real one. That's how I take the most of what AWS has to offer. With all that, my goal of building the DDoS resilient application that is online no matter who tries to attack it is accomplished. And our heated debates with the business owner are all about which dog breed is the smartest and what new online lessons our students will love the most. There are a few resources that help you to dive deeper and further explore DDoS protection on AWS. My personal favorite is the white paper, which covers many valuable points. Links should be available in the additional section. Everything I learned about AWS security is included in a variety of trainings, both online and classroom. Check them out and keep on building. Thanks for watching. Your feedback makes a huge difference and means a lot to us. Please leave it in a few seconds survey.